Name is Muhammad Hakim bin Luqman, and today I'm going to show you about the project, about the assignment 1 of the digital signal processing. So the topic is about familiarize with Scilabs. Okay, for this task, the aim of the purpose is the assignment 2 is familiarize with a Scilab. So the task is that first task is we're going to use a sine wave with 1 Hz frequency to compose a square, triangle, and sawtooth wave and plot each harmonic and approximate wave. So basically I'm going to show you about the fundamental about this square wave. So you know that square wave is a non-sinusoidal periodic waveform in which the amplitude alternates at a steady frequency between fixed minimum and maximum values with the same duration at minimum and maximum. So this is the wave that we're going to do. First of all, we're going to do a sine wave, and then from this sine wave we're going to compose it to square wave, triangle wave, and lastly is a sawtooth wave. So I'm going to show you this is how I'm going to plot the square wave. So this is a sine wave this is a sine wave, and this is the equation for the sine wave, and this is the equation for the square wave. The square wave that appear is this one. So this wave will appear when I put this kind of equation, and this one is the harmonic equation, and basically the equation you can get it on this slide, which is this. You can use this equation for the analysis. So you can see that for pi and k is the harmonic. So you can make it from k1 until k5. So what I do is I do it from k1 until k5. So if we run this, then you will get the square wave. So as you can see, this is the equation that I said before. It will show you like this, and this is the first harmonic, and then second, third, fourth, and fifth harmonic of square wave. As you can see, for the sine wave is a yellow one. So the other one is, we all know that this is a sine wave, and for the green one is the first harmonic. For it is a first harmonic. Second one is cyan. So magenta, yellow, so it will be smaller, and the one with the blue one is equation that I said before, which is this equation. It will show you this kind of square wave. So that is basically the square wave one. And next one is I'm going to show you the triangle wave. So the triangle wave is actually a non-sinusoidal waveform named for its triangular shape. It is a periodic, it's a piecewise linear, and it's a continuous real function. So for this equation, I just easily get it on this using this equation. So after I simplify it, so I can get this one. I can get this kind of formula, this kind of general formula. And if we run this, so we can if we run this, we can get a triangle wave. So we can see that the blue one is the y one, and the second one is a green one. So this is the second harmonic, third harmonic, fourth harmonic, and the cyan is the fifth harmonic. So this is, so if we total up this y minus 1 minus y2 plus y3 plus my y, so this is the triangle wave that we get based on the equation at Wikipedia on triangle wave. So next one, I'm going to show you the sawtooth wave. This also you can get the formula from the sawtooth. From this kind of equation you can get this one. After I simplify it, I can get this kind of formula. So just put it in the console, in the file. Just code it, and if you run this, you can get a sawtooth. As you can see, the red one is the one that it is the overall equation of the sawtooth wave. It is combined, and you can get this one, the red one. You can see that there's the shape of sawtooth. And so basically the formula is here. So you just put on the k, you just put on the time and whatsoever inside the formula, and you can get just like this graphic windows. Okay, so that is basically the task for number 2. So we can get the square, triangle, and sawtooth wave using a sine wave, and we also have plot each harmonic approximated wave. Okay, so next one is about task 3, which is the sound processing. So I'm going to record my voice, and I will say my name is Hakim. So this is the voice.
My name is Hakim.
So this is the voice. I'm not sure if you hear that, but the voice said that my name is Hakim, and we all know that we have for the coding is just simple. CD is which CD is we're going to find the file. We're going to search the file. We're going to put the directory of the file for CD. So we can the Scilab will find our files. And this is why FS bits is actually, if we see at assignment, we have to print the file sampling frequency and a bit rate. So actually this is the wave rate. So this is the way that we can load wave sound file in the Scilab. So wave file is a string, and fs the integer and the frequency sampling in the hertz. So this one we're going to put a file sampling frequency and a bit rate. So ext is a string. So as we can see that yfs bits, it means that returns the sample rate fx in hertz and the number of bits per sample used to encode the data. So we're going back to my file. So yfs bits equal to wave rate, which is my voice, my files. So this one will load my file. This line will load my file, and I'm going to plot my voice. So this is actually the graph of my voice. So that's how we're going to load the wave file in the Scilab. So that's all from me. We actually have fulfilled all the tasks. That's all from me. Thank you.